Welcome everybody to the AI demo of the day. Today we have with us Aakansha, one of our senior data scientists from Client Engineering and the Data Science and AI Elite team based in New York. Hi Aakansha, how are you?
Hi Armand, I'm good. How are you?
I'm very good. So we saw the other day with Tim what are the industry accelerators, and today we have another one to share with all of you. Today is the energy planning accelerator, which I think has a lot of very special components. So Aakansha, can you share us what is this about and maybe show us a demo?
Absolutely. So let me dive right into it. Why do we need a predictive and optimization solution for energy demand planning? As we engaged with clients, we realized that planning for demand is really challenging because there can be a lot of uncertainties in terms of the patterns that we see in demand. And then optimization of resources on top of that is an even bigger challenge, especially for organizations moving into the sustainability space with the renewable units, non-renewable units, wind resources, which can be even more unpredictable. So how do we bring all of these different components together into an analytics solution that can help address the challenge end to end? Let's look at how we built a solution for that. So what you have on the screen now is what we call a project in Watson Studio, where we organize all of the different assets that we will be using. So here you can see we have some data sets, we have flows, which I'll dive into in a few seconds. We have experiments, source code, which includes notebooks, Python scripts, R scripts, languages of preference, and then we have models. So all of this comes together into the project, and we can start to build the model that we want to build. The first component of that is the predictive piece. How do we predict demand? The most important part of that is historical data. If we have historical patterns of demand, we can start to look at some of the trends and seasonality and use that to forecast demand for the next week or the next month. And here we have an example of what such a data set can look like. Now, in experiments, we have two kinds of experiments. The first is the predictive part, which is auto AI, and the next one is the optimization part. So let's look at what the predictive piece looks like. On the screen, we see that the auto AI flow is complete. So we built a forecasting model and we tested that out with a holdout set, and we can see how all these different kinds of pipelines performed against the holdout set. And based on that, we can select the best performing model and we can deploy that in a few clicks. But what this gives us is just what the demand for the next few days is going to be like. That still doesn't tell us what our operator needs to do with all of these different units that they have to optimize for. And that is where our optimization solution fits in. So if we switch to the second experiment that we saw, which was the optimization experiment, we can see that the developer has the option to build multiple different kinds of scenarios. So in this case, we can see D, R, and S. Each of these stands for a different optimization technique. D stands for deterministic, R stands for robust, and S stands for stochastic. The most interesting technique in this is the robust one. So let's dive a little bit more into that. Now, in this optimization workflow, we really have three steps, and it's as simple as that. We prepare the data, we run our optimization algorithm on top of that data, and we get the solution. On the screen, we can see the input fields that we used and the result that we got. So if we look at what went into this model, we see various things like the type of model we wanted. So this is a robust model, the load that we expect, some configurations around the load, renewable forecast. This is interesting because this is that uncertainty that we cannot predict. So we use some simulation algorithms to come up with a range for what the renewable energy generation can look like. We have some information about the renewable units. We have some information about the scenario we're building and some other system configurations that we need to provide to this optimization model. So it takes all of these different things as input, and it gives us a plan for these thermal units. And we'll see all of this visualized in a dashboard for the consumption of our end user in a few seconds. But before that, another really interesting thing about this experiment is that we can actually compare all these different scenarios and how they perform while we are still in the development stage. So on this screen now, I am showing you a few charts. We can see total demand. We can see KPIs for different scenarios that we are trying to play around with. Once we have the scenario that is performing the best, we can deploy that again in a few clicks. And both the predictive part and the optimization part can be exposed as simple KPIs. So for example, here we have our machine learning model. We can see that this is deployed. And if we click on that, we'll see information about the deployment itself. So we can see that there's an endpoint that we can call. And similarly, we have our optimization model also deployed. Now together, these can be consumed in a front-end application, which looks something like this. So now imagine if you are a planner who needs to bring all these units online or offline, you don't need to worry about all of that different complexity and technology that we just walked through. You just need to interact with the outcomes of these models. And that's what this end user application allows the user to do. So the user can see what the expected demand looks like, what the production will be based on the plan that we're following right now, and make sure that the expected demand stays between the ranges of production that we have planned for. And they can also dive into the details of the suggested plan. So they can see exactly when they need to bring each thermal, wind, or solar unit online or offline, such that it optimizes for all of the resources and is able to meet the demand that that is expected. And so this optimizes for cost, this optimizes for the resources, making sure that the renewables are utilized as much as possible, and at the same time helps them meet demand so that there is no spillage of energy and there are no blackouts that people might have to suffer through. So that is a summary of our end-to-end solution for energy demand planning. And that's the end of the demo.
Very cool, Aakansha. So just to summarize, we saw in this demo how you can use Watson Studio to train not only a predictive model to predict the energy demand, but also to create a plan using a decision optimization model. In this case, you use Auto AI and the decision optimization tool that is all no code, so you can do all that visually, but you could perfectly do that with Python from a Jupyter notebook. So you have all this flexibility. You also show how you can put those models into production, how you can deploy, get endpoints, and then at the end, you have like an application. This is the final application where the operator, in this case, or a business user, will actually consume those models developed by a data scientist. So all our industry accelerators, I think the beauty is that they have this end-to-end. We display the final results in that final application, and then we provide all the assets to show you how you can consume those models and deploy them and clean the data and so on. So I think this is a very cool use case, Aakansha. Thank you so much for sharing. And for everyone else, see you in the next episode.
Thank you.